Hello and welcome to this walkthrough of our next part of our probability chapter. And we're going to be looking closely at two specific ideas today. We're going to focus on Venn diagrams a lot as well. And we're going to be looking at the idea of something being mutually exclusive or mutually inclusive, and about intersection probabilities and intersections of Venn diagrams. So the first thing we're going to do is a little review of two-way tables, and we're going to be making Venn diagrams from this two-way table to answer some questions. So first and foremost, if we are looking at our two-way table, our first row is the men from the Titanic, and we're looking at survived versus did not survive, and then the total men. So if we subtract 659 from 805, we would get an answer of 146. So we have 146 men who survived. And then we can look for this missing part for the did not survive column. We have 659 men who did not survive, and a total of 765 people who did not survive. So we need to find the difference between those two, 765 minus 659, and that means it's 106 people. So that's 106 women did not survive. And then we just have one missing part here where you have 805 men plus an unknown amount of women would have to be 1,207 people. So the difference between 1,207 and 805 is going to be 402 people. So remember, with two-way tables, you basically have your one category of things, and then your other category is usually horizontal. And all the rows have to add up to your total in the end, and then that adds up to your grand total, and then your columns add up to the totals on the bottom for both of these columns, and those add up to your grand total as well. And all of that should add up correctly if you did it right. So we're going to be making in number 2 some Venn diagrams for these three situations, one of them being we're going to choose our own. So if you want to take a second to make sure you have copied down this table into your notes if you haven't already, and I'll pause the video there to do that. And we're going to go to the back of my page to draw my Venn diagrams for this situation, and make first our Venn diagram of men versus women, and then women versus survived, and take a look at that now. So for starters, in number 2, for 2A, for number 2A, we're going to make a Venn diagram of men versus women. So we could have one circle of all of the men passengers, all of the circle of the women passengers, and we can fill in the amount of men, 805, and we have 402 women, and that adds up to our total of 1,207 from our front page. And so that is something right there we can find. And we can find some pretty basic probabilities with that. So probability of selecting a man from this group would be 805 over 1,207. Probability of selecting a woman is going to be 402 out of 1,205. So pretty basic stuff. And we can make those into decimals or percentages if we wanted to. So if we are looking at these two, obviously there's no intersection here. There's no middle area of this Venn diagram. So this sort of Venn diagram is known, these are mutually exclusive. So if they are mutually exclusive groups, that just means there are no intersection. So we could say that it just means there's no intersection. They have nothing in common. No intersection, nothing in common. So if I wanted to know probability of selecting a man and woman, that is an intersection, which we know is man, and then it's an upside down U for intersection. And then women. So the intersection here would just be 0. There's no crossover between these two things. And that is the case for all mutually exclusive things, or just things that can't happen at the same time. Moving on to number 2B. So our new Venn diagram is going to be a little bit trickier. So make sure you have your table in front of you for us to do this. So our new one is going to be the number of women versus the number of survivors in this situation. And that's the first thing we're going to ask: women versus survivor, making a Venn diagram of that. So if I want to make that happen, I need to have a circle for women, and then a circle for survivors. And then I need to basically create my Venn diagram from that. So if you look back at our data here, we basically have a certain amount of women on the ship. So we could write our number of women off the side. So the women on the ship, we know from our last one, is 402. And survivors from the ship, if we flip back to our front page, survivors total was 442. So survivors 442. Yep, 442. And we also need how many women survivors, what the intersection of that was going to be. So on a two-way table, it's easy to see. They intersect women and survived 296 people. So the women and survived equals 296 people. Yeah, 296. So what we can do to make our Venn diagram a little bit easier to see here is that we can fill in the 296 in the middle for both. And that 296 is a part of our women's circle and a part of our survivor circle. So we need to show that in our Venn diagram. So out of the women, there's 402 women. So 296 of them survived. So the remaining number of that 402, if we subtract, gives us 106 women who did not survive. And then when we look at the survivor circle, we have 442 total. So if we take out the women who survived from that, 442 minus 296, we get 146 survivors that were not women. And that is some different probabilities that you can find. So if we wanted to write out some probabilities here for our situation, we could think about a couple different ones that we could find. So two probabilities that we can find with this is that we could do the probability of a woman and picking someone who is both a woman and survived. So that's intersection, remember. So that is the same thing as woman and a survivor. So remember, that's just the intersection of these two Venn diagrams, or circles on our Venn diagram. So that would be 296 people out of the 1,207 total people that we had. And you could find that answer in your calculator if we wanted to find our decimal answer, 296 over 1,207. So 24.5%, or about 25% of the people were both women and survivors. So a fairly high percentage there. So another one we could do is a conditional probability. So the probability of being a woman given that you survived. So remember that the survivors is what we're picking out of. So the total survivors is 442 people. And then out of that number, how many were women? So of the women that survived, 296 were women out of the total survivors. So we would have 296 is the women part of the survivor circle. And we could find that probability on our calculators. 296 divided by 442 equals about 67%. So that's basically 67% of the survivors were women. More than about 2/3 of them were women. And this was about 25% earlier. So those are two probabilities that we can for certain find given that we have a intersection here to deal with. And we've done that sort of thing a little bit before. So in part 2C, we want to make our own Venn diagram. So we're going to make one here, pick a different color. So we're going to do men versus not surviving, which we'll abbreviate as NS just to make things easier. And we'll do an M for men. So we can draw our box. And so we know we have a men circle. So our men and our not surviving circle. So if we first want to fill in our missing piece here, like how many were both. So if you look on our front page, so men and not surviving was 659 people. So 659 would go on the middle of our new Venn diagram here. So the total men, if we look back here, so total men was 146. No, that was not correct. So total men was 805. 805 total men, and then not surviving. So men who did not survive, or total not survivors, 765 people. So 765 people didn't survive. So we just need to fill in the rest of our missing pieces from our Venn diagram here. And so we have our men's circle is 805 total. So out of that, we take away the 659. We get 146 left over. And we have, out of the 765 non-survivors, we can take away the 659 men who didn't survive, and we're left with the 106, which would really be the amount of women who survived. Do you think about it in terms of that way? So remember, like this 106, that is non-survivors, but not men, because it's outside of the men's circle. So we've made that, and then if we have basically all of these left over, so outside of that, 296 is representing if you're neither a man nor a survivor. So that would basically leave women survivors as the 296 total. And we saw that in our last probability up here in the corner, 296 was accurate. So we're going to find a couple of probabilities here. So the first thing we can do is we could find a probability of being a man given that you did not survive. So the not surviving goes on the bottom. So non-survivors was 765 people. And out of those non-survivors, 659 of them were men. That's the crossover between these two. So that percentage, 659 out of 765, is about 86% of the people who died, out of the people who died, were men, which is a very high percentage. If you know about how the Titanic works, that may have not been very surprising to see. So we have then to look at probability of being a man and not surviving, which we want to denote as the intersection, upside down U. So the crossover, we had 659 people that were both out of 1,207. So the probability of picking somebody who's a man and didn't survive ends up being about 55% of the people were a man and didn't survive. And that's a different answer than picking from the 9 survivors, what percentage of them were men. Different probabilities. So if we wanted to keep finding some more here, we have the probability of being a man was 805 out of 1,207. Probability of not surviving is the 765 out of 1,207. So we can find those probabilities really quick. 805 over 1,207 was about 67% men. And this is 765 over 1,207 was about 63%. So now lastly, if we wanted to find the probability of being a man or not surviving, which is a union, probability of man union not surviving, we need to find the probability of being a man or not surviving. So like what we could start with is like, well, we could find the probability. We know it's 67% for men. And then we can add that to the 63% probability for surviving. Because whenever you see or, you're pretty much adding. But here we know that we are over 100%. So whenever you see that happening, you need to take away the middle part, that's 659, which is the 55% here. Because we counted the middle in the men's circle, we also counted it in the non-survivor circle. So we counted this middle part twice. So we need to take away the probability of both, which is this 55% right there. So if we take away 55%, that means that our answer, 67 plus 63 minus 55, ends up being about 75% chance of picking somebody who's a man or didn't survive in this particular Venn diagram. And that completes all 3 of these. So the difference between something like number 2A and number 2C that we just did, these two are mutually exclusive. So if I wanted to know the probability of being a man or a woman, you would just do 805 plus 402. And that's when there's no intersection. When there is an intersection, you still do the same thing, 805 plus 765, but then you have to subtract the middle once in order to get your answer. A final thing on this is that you can also get that same answer by doing just all 3 parts of your Venn diagram added together. So this is demonstrating what is known as the addition rule. For mutually exclusive events, you just add the 2 things. For mutually inclusive events like 2C, you are adding them and then subtracting the probability of both happening. And let's move on to the front of the page, back to the front. All right, so we took care of number 3, and we made probability statements for all of our Venn diagrams from question 2 and reviewed that a little bit. And so we need to set up some Venn diagrams for these 4 things on the front here. And so we're going to make a Venn diagram for girls versus art, and then we can make one for boys versus not art and kind of see how that ends up going and talk about that a little bit to wrap this up with some summary questions at the end. So you want to pause it and copy down all 5 of these kind of questions here. And we're going to kind of make some probability using mostly the top numbers, because that's like the number of people out of 100, because that's the sample size. So everything's going to be out of 100 for the most part. So let's move to the back and make some Venn diagrams for number 4. Okay, so we have number 4. Let's kind of make a little divider line. So number 4, our first Venn diagram is going to be girls versus art. So we know girls was 42 total and art was 30 total, and we can double check that on the front. So you see girls 42 people, art was 30 people. So we did that right so far. And so we are looking at this, and we have one circle for girls and one circle for art. So we know from the front, if we flip back again, so we know girls and art. So this is kind of like this one. This probability right here is basically probability of picking a girl plus the probability of picking art minus the probability of picking somebody like who is a girl and chose art, is how that is set up right there. So this 12 right here means the probability that there's 12 people who are both. So we can go into our Venn diagram and write 12 in the middle. So out of the 42 total girls, if we take away the 12 that are both, that means there are 30 girls who did not choose art. And out of the 30 art students, we had 12 girls. So that means we had 18 people who were art students but did not choose, or were not girls, meant to say. So out of those 42 plus 18, 60 people, well, that means there's 40 people left over out of the 100 total in our sample space. And if we want to start filling in some stuff over here, we need the not art and the boy ones. So we have here mutually inclusive. So remember that this is intersection. So that's definitely mutually inclusive. So we could come down and at the bottom here, we can make one that is art versus non-art. So art versus non-art. Didn't mean to draw it like that. So it would just be, we have art and then we have non-art, and those are mutually exclusive. You can't pick both subjects, either in art or you're not in art. And so we'd have 30 people and 70 people. So if you say the probability of art or non-art, well, that's just 30 people plus 70 people out of 100. And that's just everybody in this case. But it wouldn't always be everybody, but that's kind of what is happening there. So our last thing we wanted to do was to look at boys versus non-art. So we know that there are 58 boys, and there are, if you look at the front, non-art would be 70 because it's kind of like the complement of this one. So if there are 30 art students, that means there's 70 non-art students. And if there's 42 girls, non-girls would be the other 58 people. And so we have 70 non-art students. So let's start filling in our Venn diagram here. So we have a boys circle and a non-art circle. So we need to figure out how we could find some of these probabilities. So we know a couple things to start off with. So if we look over at our probability over here, so we need to figure out, like, well, how many, so if we have art students, is 30 total art students, we can look at, well, I know there are 18 art students that are not girls. So that means that there are going to be 18 boys who are 18 boys that are art students from this Venn diagram. So these 12 art students are girls, these 18 art students have to be boys. So we have 18 boys that are in art, so that we wouldn't be part of the non-art section. So if we have this total boys circle, 18 plus 40 would get us to 58. So we have 40 people there that are both boys and non-art, since the 18 was the boy art students. And if we have non-art, that means there's 70 total, meaning there's 30 left over. So if we wanted to find some probability answers from that Venn diagram we just made, remember this is mutually inclusive, they have some overlap. The one down here was mutually exclusive, since there was no overlap. And we can finish this off. So we want to find some probabilities, that probability of not art and probability of a boy. Well, I mean, those are easy ones to find. So here, some practice with some ones. So probability of being a boy in this case was 58 out of 100. So the probability of non-art was 70 out of 100. The probability of being a boy and non-art, well, that's the 40 in the middle. 40 out of 100. So if we wanted to get the probability of boy or non-art, remember that's the union, that means or. If we have a Venn diagram, we can just add them all up. We can do 18 plus 40 plus 30 out of 100 people total. And so that would be 70 plus 18 is 88 people out of 100. And remember, you can also do that by doing the 58 people who are boys plus 70 non-art students minus 40 that are both. And so if you did in your calculator 58 plus 70 minus 40, you would get 88 people again as your answer. And so you have to use this sort of formula when you are doing mutually inclusive events, but mutually exclusive, you can just add them together without having to subtract. Let's flip back to the front and wrap up our last few questions here. So if we are thinking about number 5, describe the conditions that create mutually exclusive Venn diagrams, and those create intersections. So basically, we could just say that mutually exclusive events, they can happen together. No overlap at all. And so when there is intersection, that's the opposite. Those can happen together. So, and then additionally, if you have two events, like the probability of A and B happening when they're mutually exclusive, that's just 0. Because if they can't happen together, the probability of them both happening, or probability of something having both, is 0. And so the probability of something can happen together, that is never going to equal 0. Probability of A and B does not equal 0. So lastly, you want to think about Venn diagrams as far as highlighting probabilities. So the probabilities you want to it can highlight the best or the and probabilities where you intersection. So remember and intersection are these all mean the same thing. And that's an important thing to remember. And that basically wraps up the classwork for 9.4. Thank you for watching.